All right, good morning, everybody. Welcome to Wednesday. Today, we're going to hear from the LSST Science Collaborations. Each one is going to present for a few minutes and tell you a little bit about what they've been up to. First, I do have some announcements. The regular reminder that we do have a code of conduct and that we have contact people who are available to speak with you if you witness or experience any violations of that code. Reminder to wear a mask if you want to, and to get those stickers on your name tag if you like, and to keep an eye out for those social battery pins. Reminder for our virtual participants to please stay muted while you're not speaking. Use the Slack to ask questions. And yeah, we'll get those questions. Either we'll invite you to unmute to ask, or we'll ask them for you in the room. Another reminder for the in-person participants that there are room monitors so you can see how rooms are filling up in the morning plenary. This room still has space. If you're listening via Zoom and you want to come and join us, there's still seats. A couple of announcements. Today is the unconference. That's at 4 p.m. It's going to be in all rooms. The way it works is you put topics up on the board that you suggest, anything you think we missed in the agenda, or a co-working session that you want to have, or a discussion on an emergent topic, maybe that's arisen in one of the breakout sessions. Pop it on the board, people vote for it. At the end of lunch today, or 15 minutes before the end of lunch, I go and I see what the top three topics are. I assign them to rooms. You will find the room assignments on the session page in the workshop website and on Slack. And you look at the options, pick one, and you go have fun. You'll arrive in the room and it'll probably be a pretty informal discussion. There's no chair, nobody's prepared anything. You'll just sort of show up, discuss the topic, co-work, organize yourselves, have a good time. If there's any questions about that too, you can ask in the Slack channel about the unconference. I put pictures of the current topics and their votes also in that Slack channel, so you can see how things are tallying up so far. A reminder to our virtual participants to send us your photo so that we can include you in the group picture that we took yesterday. Another reminder that the Slack control room is going to have an open house at 5:30 p.m. today. There will be two people there, Shuang and Eric, will be showing you what it's like to observe on the summit. So you'll be able to kind of shuffle into the control room and see what they're doing and take a look at all the cool software that they use to control the telescope. That is in this building. It looks like Bill's got instructions to enter the building by the back door, and then you go downstairs to level 1, and it should be on your left. And then we have another new addition to the agenda, LSST Cam, a single raft tower module show and tell session. So Hannah and Travis have a single raft, like one piece of the camera. So you can kind of see the single raft is kind of poking out in that image there. They have one for you to see. So Thursday, 12 p.m. in the SUSB lobby. That's where the coffee and the posters and the check-in desk are. So you can go there at 12 p.m. and see one little piece of the camera. All right, that takes us to today's presentation. We're going to have speakers from all of the science collaborations, but we're going to start with the interim science collaboration coordinator to tell you first a little bit about what the science collaborations are in general. Gautham is joining us virtually. Gautham, can you unmute?
I have. Hopefully you can hear me in the room.
Yes, we can hear you fine, and I'm here to advance your slides as you go.
Thanks, Melissa. First of all, I'm very sorry to not be able to make it there in person. This is the first RCW I've missed in about 10 years. So I'm wearing last year's shirt as a memento of all the fun that I'm missing. I'm currently the interim science collaboration coordinator, filling in for Will Clarkson, who's convalescing and should be making a full recovery and be back here very, very soon. He's doing great. But while I'm filling in for him, what we're going to do today is just go through all of the science collaborations and get some of the key highlights from them. This session's a little bit abridged from previous years, so we will have only about 6 minutes per science collaboration. The science collaborations themselves are these independent, self-organized groups that are really focused on different research topics. Now, there are 8 of them, and there are over 2,000 members already. They are governed by the Science Collaboration Federation Charter, but each have their own rules and policies. There's just a few common elements to all of them that govern their structure. So there's regular elections, there's no membership fees, there's no institutional affiliation requirements. And for basic membership, in fact, there's no time commitment that's needed. We strongly encourage students to join these science collaborations and really get into the work of preparing for Rubin Science. And that's what the science collaborations are going to focus on today. So next slide, please. Like we said, we'll go through each of the science collaborations. They'll share an aspect of their plans for early science with data previews or the first data release with Rubin, and what they need from the observatory in order for them to be successful. Again, this is an abridged session, so they've only got 6 minutes to do this. This is really, really hard. If you have any questions, and I know you will, please hold them until the end or ask them in the Slack channel, which I've listed down there on this slide. And without further ado, let's go to our very first science collaboration that we'll be presenting, which is the Dark Energy Science Collaboration, where you'll hear from Tesla, who should be in the room. Can we move on to desk slides? Yeah.
Thanks, Gautham. So yes, I'm Tesla Gautham. I'm here representing the Dark Energy Science Collaboration. I'm the current deputy spokesperson of DESC. Our spokesperson is Renee Lajek, who's also online. So as the name implies, DESC is focused on using LSST and Rubin for cosmology. This includes constraints on dark energy, neutrinos, but also the nature of dark matter. We have over 1,250 members and more than 250 full members. If you're interested in joining, there is a link that has more information on how to apply for membership, but please, you're welcome to come speak with me or anybody else you know in DESC about how to join. So our work is then accumulated into a number of working groups, including analysis working groups, computing, and technical working groups. And one of the changes we've had over the last year is a reorganization of some of this working group structure, in particular to try to accumulate together groups that really have common goals or common needs, and also to streamline some of the communication with Rubin. So for example, on the technical side, we now have working groups called pixels to objects and pixels to light curves, whose focus is all of the things you need to do to go from, pixel level data to the data products that then feed in to our analysis working groups. Okay, can I advance the slides? Is this the? Yes. Okay. So in terms of, early science and some of our early science goals, a lot of these are focused around like really just, testing out all of our pipelines. But, among the things that we'd like to do are to test our alert responses. So, for example, our automated routines for classifying and recommending transient objects for follow-up, seeing, how well we're doing on our like supernova sample selection. Things like applying some of our cluster finding algorithms in the early data and testing how our selection is going. End-to-end tests of our cosmology, like the 3x2 point pipelines to see how those are doing. Demonstrating that we can find interesting and sometimes rare objects like strong lenses, low surface brightness dwarf galaxies, high redshift galaxies. And generally, testing, making sure that the, PSF modeling, deblending, photo Z estimation are what we need for the DESC cosmology analyses. And, we're also thinking about another recent initiative is an early science planning task force. So this is really around, what procedures and policies we want to be thinking about when it comes to early science and early science papers, and making sure that those go smoothly, are supported, and happen in a collaborative manner. Okay, so in terms of needs, for our cosmology science goals, DESC has needs both in terms of like we have transient probes like supernova, and then we have our static probes like 2-point large scale structure, cosmic shear, clusters, and those have different needs in terms of survey strategy and compromises to be made. So for example, for transient science, a rolling survey strategy is extremely important. But then for our so-called static probes, we really need uniformity. And so one of our needs is to balance those. So we've recommended in particular a so-called uniform rolling strategy where you get at, intermediate years, not just year 1 and year 10, but also like in years 4 and years 7, a uniform coverage for enabling static science. So, we've developed figures of merit for this, and, essentially this boils down to, if there's non-uniform, our static probes get limited to the area of the survey that is uniform. And so that can reduce, our figures of merit by, 30% or more for the static science. So this uniform rolling strategy maintains most of the, advantage of rolling for the transient science, while also enabling our static probes in several intermediate epochs. At the same time, again, on the deep fields, there's compromises. Like, the deep fields are needed for us, both for our photo-Z estimation and so static probe calibrations, but also for transients. And again, here a compromise where, at least a certain percent of time is dedicated to deep fields, and also that there are some ultra deep fields along with regular deep fields, is what will again maximize both the static and transient science for the desk side. Our other needs are, we need good templates for the transients, co-outed and calibrated images. Again, I've already mentioned, but like photo-Z, robust photo-Z estimation, and being able to model how the photo-Zs translate all the way through into our cosmology, and understanding the PSF modeling, and again, how that propagates to things like our shear estimates. And so I think that is it for me. And I don't know who's next.
Thank you, Tesla. Next up, we'll have the Galaxy Science Collaboration, and Simona May will be presenting on Zoom.
Hi, good morning, everybody. I'm in Palo Alto, but unfortunately I cannot be there in person because I got something on the plane. So I am one of the 2 co-chairs of the Galaxy's Science Collaboration with Sugata Karirai. And our collaboration is around 310 members, and new members are welcome all the time. So you have the webpage link just here in green. You can click on it, and you can apply for membership. Everything is explained on the webpage. Our goal is to understand galaxy formation and evolution, and the LSST depth and area will give us an unprecedented view of our field of research, especially in certain areas that are explained in the roadmap that was presented in these 2 papers, Robertson et al. 2017 and 2019. There will be very large statistics down to the faintest galaxies, the connection between galaxy properties and the dark matter halos, and low sulfur brightness features around galaxies like tidal tails, major remnant, etc., that can connect this observation to models of galaxy formation and evolution, and the galaxy cluster intercluster medium. Next slide. This is an example of low sulfur brightness features that we expect to observe them with the LSST. So you have an SDSS image on the left and an hypersupreme camera image on the right, and the upper supreme camera is at the depth that we expect for LSST. You see how all the features around galaxy just pop up, so that this will be a discovery field, a new discovery window that we will have with LSST. So the main challenges will be to identify the most critical LSB features that can constrain theoretical models for galaxy formation evolution. And there is a large effort to make consistent measurements in observation and simulations with 3 papers that we were published in the last years that are mentioned here. Next slide. During commissioning of first observations, what we are concentrating on is to test and validate our methods for detecting the LSB features, galaxy morphology, classification, and structural properties, robust galaxy photometric redshift, the estimation of galaxy mass, star formation rates and ages, and to quantify galaxy environment and detect galaxy clusters. So we are developing high-performance tools, algorithms, some in-kind contributions for galaxy deblinding and multi-wavelength observations, and catalogs that will enable us to study galaxies not only in the optical with LSST, but also through the infrared, radio, and submillimeter. Next slide. So the survey and data products needs for success. As mentioned by Tesla, we also need uniform depth and strongly endorsed the request by desk of having uniformity more often than planned. We also need a U-band depth that permits identification of high redshift dropouts and measurements of dust extinction. The data reduction with the dithering pattern that permits efficient LSB feature detection, so that we can have an adapted LSB reduction. PSF match the blended multi-wavelength catalogs and tools for adding ancillary data, so that everything will be done in a homogeneous way. A robust sky background estimation, a robust galaxy photometric redshifts, and a good PSF model in each band that is very important for the measurement of galaxy structural properties. Thank you.
So our next speaker is Ashley Villard, who will be telling us about the Information and Statistics Science Collaboration. Ashley?
Yeah, thank you so much. I also apologize for not being there. I was on my way and I got stuck in my layover for 3 days, thanks to Cyberstrike. So I have to join virtually, but I'm excited to tell you so much, at least a little bit, about the Informatics and Statistics Science Collaboration of LSST, which is co-chaired by myself and Francois Lanous. We have to defend ourselves. Can you forward? This is not my full slide showing. Oh, it has transitions. Francois made this and he does a great job. Okay, so I want to first say why we have this kind of non-science focus in a science collaboration. And we argue that LSST is such a transition in large data that we really should maybe work collectively to think about hard statistical problems in data-driven science that we now have to do with the LSST mission. And so what ISSC really focuses on is helping other scientific collaborations think about these challenging statistical problems that they are facing in their own work. So next slide, please. The ISSC has been really actively evolving in the last year since the last time Francois presented to you. We've done a major restructuring in 2023, including finally ratifying our charter and defining an organizational flow, including interest groups. And can you go to the next slide, please? So I'm also excited to say we had our first collaboration meeting that was held this year. What was exciting about this is that we were able to bring together a number of representatives from other scientific collaborations to get a better sense of their kind of statistical problems, and to better organize how we can communicate with those groups. And so one way that we can do this is through this new creation of our interest groups. If you go to the next slide. Oh, so sorry, one more slide. I really want to highlight the creation of the new anomaly detection interest group, which meets bi-monthly, and everyone is truly welcome to join. The goal here is if you're just at all interested in anomalies within LSST, if that's in images, if it's in time series, you tell us, even if it's in audio detections from the observatory itself, you tell us, and that's what we're interested in solving. That's co-chaired by Kostya and Ashish, shown here. So there are two currently active projects. One is a challenge through the elastic large group effort, which is to search for anomalous transients in a large simulation of LSST-like light curves. And a second is the STAMP classifier, which is using the Zwicky transient facility to try to find really strange anomalies within the STAMP images themselves. If you want to hear more, please do feel free to join the Slack channel on the LSST Slack, which is ISSC-AD. Next slide, please. I want to emphasize one more time that our goal very much is to connect, like this image shows, with the other collaborations and to help you achieve the science that you want by creating new formalisms to do so. So one more slide, and then that will be it. I just want to say, as we start to really approach the start of LSST, one thing that would be so beneficial is to start really thinking about getting together with other scientific collaborations and having conversations. Virtually, we're lucky that we can have things like joint talk series where we can understand the problems and solutions that are arising in different scientific collaborations that we might not be talking to. But then also we might be thinking about, as the data comes in or before, doing in-person hacking and getting together and getting our hands dirty with some of these methods. As part of that too, if people are interested, the ISSC is interested in doing things like large-scale data challenges that are open to people beyond the astronomy community, so including ML engineers, data scientists, people in industry, through something like a Kaggle competition. So if that's of interest to you or your group, please do feel free to reach out via Slack or email. And that's all I have. Thank you.
Thanks very much, Ashley. We're moving straight along into the Solar System Science Collaboration, and Colin Narayan Chandler, who's one of the co-chairs, should be in the room and able to present there.
Yeah, just before we move on, I want to mention that ISSC is hosting the Brown Bag Lunch today over in Trinity. They want you to come and talk to them about what you might need and opportunities to collaborate. So go to that lunch if you're interested.
Hi, yes, I'm Colin Ryan Chandler. I'm a project scientist for LSST Interdisciplinary Network Collaboration and Computing at University of Washington and DRAC Institute. I'm talking about the solar system collaboration today. So we're a couple hundred members strong. I'm co-chair along with Meg Schwam, who we all know very well. We have a couple early career representatives in the group, Carrie Holt and Maria, and we also have publication coordinators and our EDI committee representative, Laura Ino. So we're divided, in addition to sort of parent activities, we also have these working groups. There's active objects, so comets and active asteroids, led by Henry Shea, who's here. I should have also said that, I guess you know that I'm here, but Meg Schwam is online, Maria's online. We have a software working group, which is very active, led by Tim Lister. Inner Solar System is from Siegfried, and Sarah Greenstreet, who's here, leads the Near Earth Objects group. Outer Solar System has Pedro Bernardinelli, who is online. And we have a brand new Techno-Signatures think tank, which we are spooling up and looking for interested members, run by Jim Davenport, DRAC Institute. So just some highlight for the activities we've been up to in the last year or so. We've been working on changes for solar system data schema and that have gone through. We have been working for writing proposals for both funding as well as for observational follow-up for LSST. And we're advocating for commissioning observations to confirm active solar system objects, again, like comets, coordinating our in-kind software contributions, thinking about how we can sync up everybody across all the time zones has been focus. And evaluating year one incremental templates is one of the things that we're sort of laser focused on right now. We've had a number of gatherings in the not too distant past in 2018, and then for some reason we went virtual for a couple of years. And then we had another one in Flagstaff in 2023, and we have another one in Oxford in 2024. That's in September. So if you're excited about that, registration is technically closed, but if you're just so bummed about that, you can talk to me and we can see what. One of our other spotlights is we have this Sorka survey simulator, which is coming out. It simulates LSST, the observations, cadence, etc. And it can take different models as its input. We have other things on the horizons. We're suddenly discussing satellite impacts on observations. It's another activity. This is a Link Frameworks Incubator awardee, and there's a bunch of papers in prep, so we encourage people to check it out. Stay tuned. I mentioned incremental templates. We'll just emphasize we think they're super important, and so we're really focused on that right now and excited to participate, especially in commissioning and beyond. We're advocating for updates constantly about the incremental templates and real bogus as well, since that's going to help us with alerts, and comment testing. I think I've mentioned that 3 times. I'm a little biased, but it's very important. And just to mention our website, you can check out lsstssc.org, and there's QR code, and that's a great way to reach out to us. And you can also find me on Slack as well as Meg Schwam. Thank you very much.
Thank you, Colin. I believe the next presentation is going to be from stars, Milky Way, and local volume. Who
Yep.
I
Hello.
hope
Can
is
you
in
hear
the
me,
room.
Gautham?
Yes, we can.
Hello. I don't know. I'm looking at the screen. You're not in the screen. Yeah, somewhere up there. Oh, I've got the button. Hello, everybody. Yeah, so I was asked to just present on behalf of stars, Milky Way, and local volume. And unfortunately, the last minute changes I made to this aren't there. So check the link in the agenda for bits and pieces. I put the website up there last minute. I realized I completely forgot to put that up there. But for stars, Milky Way, and local volume, it's a bit of an odd science collaboration if you think about it, because it's everything that isn't in another one. That's how I sort of think about it. You know, it's not galaxies, it's not things that change, but it's still three separate things. So when I was asked to think of an early science goal, kind of had to put three up here, because for stars, people are thinking about in the star clusters working group how they can accurately detect the extragalactic globular clusters, because we can still claim stars from the galaxies that are not the Milky Way, but also as links to the ISSC there's thoughts about machine learning for classification. And then in the Milky Way, more specifically at a slightly broader scale, people are thinking about how LSST can extend Gaia and how those two data sets can complement each other. As I show there, the precision should just about complement each other, and LSST will basically extend things like proper motions and parallaxes even fainter, and so that's particularly important for the solar neighborhood. Think about brown dwarfs, which aren't even stars at all, technically. You know, we can argue about that if you like. But lastly, which started off with the Crowded Fields Task Force, but then you see my ellipses there, is sort of a thing that a lot of SMWLV are thinking about, is the thoughts about crowded fields, you know, particularly for the bulge, where we're going to get the wide, fast, deep cadence for time series studies. These fields are all going to be crowded in the Rubin data, and how on earth do we handle that? So then if we're thinking about for success we need was my second prompt that I was asked to talk to. Recently, SMWLV has started thinking about astrometry, so I thought that was a rather convenient thing to mention as the thing we need for success, as the thing we're sort of worrying about at the minute, I guess. And if this is something that is concerning for you, I'm hoping that we will have an unconference session this afternoon. So if this concerns you or you were concerned before, please go and vote for it. But we need to understand the astrometry, and the basic thing that we need to understand is the centroid astrometry, the idea of, you know, do the uncertainties or the covariances that the LSST pipeline provide, are they precise, are they accurate, are they robust? And, you know, we can check commissioning data to some level, and then early science with DR1 to check that the pipeline is doing what it's supposed to be doing. But beyond that, there's sort of all these higher order problems, such as what will happen in crowded fields with open clusters. You know, can we identify these clusters from positions, proper motions, all these things in these crowded fields in Rubin? Can we gain new star clusters? This sort of thing. And again, the final bullet point on the previous slide on crowded fields. This is something close to my heart because this is what I've been working on for the past 5 years or so. How do we quantify and understand the crowding and the effect that the crowding will have on astrometry, but also the effect that the crowding will have on photometry? Or on the right-hand side there, I'm just showing tentative evidence that we discovered that in the WISE data, there's about 30% flux brightening, and there will be about 10% flux brightening in crowded fields in LSST. So if you've got 1% photometry, if you've got precise photometry, it doesn't really matter if you're systematically biased in the brightnesses of the objects. How do we handle that? And again, you know, this idea that we want to extend the LSST data from the optical into other wavelengths, this then will have knock-on effects again. And this is, I guess, Chair's prerogative while I was putting these slides together again, another example from me on how this will affect the idea of combining LSST with other data sets. I believe that to be my last slide, so I will leave it there. Thank you.
Great. Thanks a lot, Tom. Next up, we should have the Strong Lensing Science Collaboration, and Anuprita More should be in the audience and able to present.
Hello. Yeah. Hi, everyone. I'm Anuprita More. I'm a research faculty at IUCA in India. I would like to firstly thank Rubin and the funding bodies for supporting my travel so that I can attend this workshop in person. I'm a newer member of the users committee, so some of you may have seen emails from me. Please respond to my emails and give us feedback on the Rubin Science platform and other data products. Anyhow, so today I'm going to talk about the strong lensing science collaboration key activities and highlights. Uh, uh, this is um, this is on behalf of the SLSC co-chairs Graham and Simon, who could not be here, but I would like to thank them for putting together all these slides. So the the science that we can do with the strong lensing spans a very broad scope, right from doing cosmology to studying the nature of dark matter, from massive clusters to individual galaxies. With some low mass lensing or micro lenses, we can study the inner structure of AGNs. We can use lensing as a natural telescope and study very high redshift galaxies and look at the very early stages of galaxy formation and evolution. And last but not least, we can use lensing for studying physics of explosive transients. Also, via the multi-messenger astronomy, we can study the nature of their progenitors. So some of the collaboration-wide activities that are happening, they involve um, development and testing of different pipelines and setting up challenges, which can help us simulate different kinds of lens systems, discover them, and make predictions with the lens modeling and so on. Some of the activities are focused towards transient science. For example, setting up watch lists, which can monitor known lens systems and any triggers that are happening in those. There are also other activities specific to the transients, for example, the image quality, developing optical methods for stacking of data, uh, difference image analysis, and targets of opportunity observations. These are extremely important for getting appropriate timely follow-up for the lens transient candidates. There are other activities, for example, setting up databases which can gather information about newly discovered lens systems and any sort of follow-up that happens, plus also communicate with the all-sky watch lists, and not to forget the massive follow-up efforts that are needed for any lens systems that are found, and by writing proposals and doing the actual observations and subsequent data analysis. This is extremely critical for enabling the science. So some of the requirements for making all of this happen are we need rapidly generated cutouts. We also, being like a rare kind of science that we do with strong lensing, we need non-standard alert packets. We need optimal image quality stacks, both stacks as well as single visit cutouts. For lens systems, we are looking at mostly star-forming galaxies at high redshifts, so bluer bands are very important for us. And then there are other requirements that go into doing science with lens transients. That includes, again, difference image analysis, and efficient recovery of these faint systems, so inter-visit night stacking, and again, target of opportunity observations are extremely important for us to be able to follow up these candidates. So some of the example of early science could be studying some of the first lens transients, could be supernovae or kilonovae, and studying them at high redshifts, understanding the physics of the compact objects. So to facilitate the success of this kind of science, we need to be able to do difference image analysis in bright or crowded fields. We would be working with partially or resolved or unresolved lens transients. We definitely need non-standard alerts and cutouts at large scales. And very important are good quality templates, which are required at a low latency, and also massive coordinated follow-up efforts, which can span different science collaborations and also different surveys like Euclid. There's going to be a transient lens challenge that we're going to set up, so please stay tuned for that. Lastly, I would like to say that we welcome everyone to join our science collaboration. There are many opportunities for especially newer junior members to join. They could join the science teams and help with different discovery and modeling challenges. Um, they can help also strengthen communication between the different science collaborations. A very good place to enter and take lead would be to help with the follow-up efforts, writing observing proposals, helping with observations and those kind of things. Also, there is scope for earning the SLSC builder status if you are happy to contribute in building many of these facilities. There are many of us here attending in person. I won't go through everyone's names, but please come by and say hello to us. We would be happy to talk about lots of different problems and challenges that we are facing. We also have monthly telcons, and up there we have the strong lensing channel name. So please join us, and yeah, I'd like to thank everyone at this point.
Thanks so much, Anuprita. We'll be going on to the transient and variable science collaboration next. But before we do that, we'll need to refresh the slides in the room on Zoom. And if we just go back to full screen slideshow mode. Great. And presenting for the TVS group is Igor Andrioni, who should be in the room.
Thank you, Gautham, and everyone. My name is Igor Andreoni. I'm presenting on behalf of Sara Bonito, my co-chair, and the whole TVS science collaboration. It's kind of hard to identify the one early science goal we have, just because intrinsically TVS is so diverse in science interest and objectives. And in fact, I would like also to thank those TVS members who have put together some slides that report the recent highlights and expectations for the early science. You can find them linked on the slides. Probably something that we can kind of all aim to do, especially within TVS, is just find the rare gems. Definitely there will be probably most of the science coming from large populations that will be accumulated over the years. But at the beginning, thanks to the depth that we will reach, the volume that we can probe with Rubin, we can go find those rare transient and variable sources, from the galactic ones to the strongly lensed multi-messenger sources perhaps, that are now so elusive. And in fact, it's also interesting that thanks to the extension of the LIGO and Virgo observing run, we might be able already to have LSST come mounted before the end of the current gravitational wave observing run. But what do we need for success? Starting from the obvious, we need templates. A lot of the science that we like doing relies on different imaging analysis. So the sooner we get high quality templates, the better. Target of opportunity observations will be key, specifically for multi-messenger science from neutrinos, gravitational waves, and they will also benefit other science cases, from strong lensing to solar system object. We will definitely need to implement and further improve selection methods for which sources to follow up and to do our science with. And we need tools that have been studied, developed over decades, and have been specifically then tailored for Rubin. such as crowded field photometry, and a whole bunch of techniques that was really awesome to see presented these days. And I think all of us are looking forward to see them put in place. Where can TVS fail? TVS science. We know that spectroscopy will be challenging. So maybe working towards more coordinated effort, like some of us are thinking about, might be a good way forward that can increase our chances to do the good science we're planning. And for many science cases within TVS, we really need high cadence. That's something kind of difficult to compromise about, just because when you miss a transient or some sampling, perhaps in the early phases, when you can better study your favorite source, if you lose it, it's gone. It's not coming back in a year, it's not coming back in 2 years. So leveraging as much as possible on cadence can truly also bridge the gap that we will have because of lack of deep spectroscopy down to magnitude 23 and 24. And I hope, I like to think we're a clever bunch enough that we will reach a good compromise so that everyone will be able to succeed in their science. And I will stop here. Thanks.
Thanks very much, Igor. We need one last update of the slide deck
Okay,
before
we're
we
on
go
it.
on to the last. Yeah. And while many of the speakers couldn't be in person because of CrowdStrike, the AGN Science Collaboration going last has a somewhat better excuse if we go to the next slide, because they're having their Science Collaboration meeting at the same time. But Franz Bauer will be presenting on behalf of the co-chairs. Franz, please take it away.
Okay, thank you very much. I found out I was going to speak about 5 minutes ago. Hello, everyone. Right, I'm speaking on behalf of the AGN Science Collaboration. I'm involved in some of the organization. And so the idea behind this collaboration is, of course, to leverage or to take advantage of the tens of millions of AGN that LSST will observe directly and detect and identify, as well as maybe several tens of millions of AGN they won't identify, but are sitting in there kind of, misbehaving and contributing to a galaxy mission. And so we are involved in a bunch of different topics related to these overarching science goals. So time variability studies, trying to identify AGN via variability, and then study the physics that we can actually extract from that variability, which might be tracing the accretion disk or jets or other phenomena. There may be binary supermassive black holes, and so searching for the signatures of those, the periodic signals that might be hidden in the variability. Then, of course, the transients that are related to supermassive black hole binaries, supermassive black holes. So this could be tidal disruption events or AGN flares of varying nature. As Gautham mentioned, we have an ongoing AGN collaboration meeting in Torino, and so many of the players are actually there on a different time zone. Next slide. So our current membership holds at about 180 members. So we've grown about 20% in the last year or so, and probably are seeing a continued growth in that direction. We have 168 associate members and 13 full members at this moment. And we're hopefully, as we're growing, the number of associate members is moving into full members in a healthy pace too. And that means we can fill various committeeships and things like that. Neil put down here the largest national memberships, so you can see kind of a breakdown of who's coming from where, and we have a healthy contribution from our international collaborators with tens of members in varying countries. Next slide. So our current sort of efforts and science highlights for the last year, we had a couple of collaboration meetings. So I mentioned the one in Torino, but we also had one in Charlottesville that was supported by NRAO and NASC last summer. And this was sort of a 35-person in-person participant plus, I think it was more online. I think it was more like 20 or 30 online. And this is how we've been able to kind of continue moving along. And we have typically 4 large working groups that meet sort of on a monthly basis and are sort of pushing along, the classification efforts, the sort of extracting science from variability, follow-up efforts, trying to sort of put in place spectroscopy and imaging programs. And then I'm missing one other working group, which I can't remember, but in general, that's kind of our organization. Fundamental redshifts. And we've also had many SAB members attending the Restless Nature of AGN meeting in Napoli, Italy last year. We had a data challenge in 2021, and that was largely we had assembled a data set in the deep drilling fields and then asked various people to find AGN from the multi-wavelength data that was there and from the variability data that was there. And a paper by Savick et al. Was accepted in AppJ last year, which kind of details that effort and kind of compares the different groups or the different results that came out of that. We had some prizes which were sort of given to us by the LSST Enabling Science Award, so that we could kind of entice people with a carrot to put in entries. We're working on a new system to sort of manage and track projects. And so this is to sort of encourage internal cross collaboration and to kind of track that. And so that's kind of in place and we're testing it now. And this might be something that other science collaborations are interested in sort of mirroring. Next slide. And so in terms of the rest, to sort of say our challenges or opportunities. And so as is, I think we've like a broken record in the past, we've mentioned that, in general, there's a pretty significant lack of funding to enable interactions with, say, the software engineers from Link to manage and kind of interact strongly with the in-kind contributors, to interact with the Catalyst fellows, and also to be able to sort of interact with the cadence optimization sort of programs or efforts that have been going on over the last couple of years. And in general, sort of grants in the order of 50,000 for a couple of PIs are needed to really, sort of enable that effort. And so that unfortunately hasn't happened. And so we're sort of struggling in that regard because people need to focus their efforts elsewhere. The other thing that we're sort of doing is looking to engage with the other SCs in meaningful ways. We are actively kind of interacting with the Galaxy group to look at deep lending. And so we're sort of pushing on that. We're hoping to see some interaction with the ISSC in terms of maybe finding some interesting novel ways to find and classify AGN. And we have some members that are sort of in both groups. So that's about it. That's all Neil and Matthew put on the slides, but I'm happy to take any questions as far as I can answer them.
Great. Thank you to all of the SC co-chairs or presenters. We're coming up on Q&A time. I wanted to thank everybody for staying on time thus far, leaving some time for Q&A. If you have questions in the room, I'm sure Melissa can direct you there, or if you have questions on Slack or Zoom, I'll make sure we get to you.
We've got a question in the room. Just where did our mic runner go? Oh, there you are. Up there. In the middle. Okay, it's on its way. to you, coming over here.
Hi, thanks for the talks. I was just wondering about how authorship rights work on the collaborations and journal articles and whose names are on papers and stuff like that.
Maybe Gautham could speak to that generally for science
Yeah.
collaboration.
So I think I can answer that sort of globally. As we mentioned at the start, each of the science collaborations have different internal rules, including different publication policies. Some of these are very brief and are actually under active development. In fact, I believe the ISSC policy, Ashley can correct me if I'm wrong, is actively being developed right now. Other policies are more detailed. So the desk one, for example, has a publication system where you declare a project, do a short project presentation, get other members from the desk involved, and once it's time to present a paper, there's an internal review, and all of the authors have to write a contribution statement for what they actually did on the project before it's submitted to archive or journal. So they can be very different. This is an area where I think, particularly in the next couple of years, you'll see a lot of activity, because as you start to get LSST data and people are starting to write the papers, shortcomings in these policies that are currently existing will become very apparent, and people will adjust them. But the key thing here is that everybody really wants you to get involved and wants you to write papers, and will do absolutely everything they can to encourage you to put out LSST science.
Thank you, Gautham. We have time for more questions.
Katrin Heidmann from Argonne National Lab and Desk. Great talks. Thanks a lot. I was wondering, so there's obviously a lot of great stuff going on in the different science collaborations, but there's also a lot of overlap, as was mentioned in the talks. Will there be more of an effort to get the science collaborations together, besides at this one workshop once a year, to really foster these interactions more? Or do you think that will just happen naturally when the data comes and we all look at similar problems?
I think, is that another question for Gautham? Gautham, if you want to take that.
Sure. I'm not sure if Jenna or Beth are in the audience, but I think they mentioned that there was a survey that's going on from LSST Discovery Alliance that asks users exactly what they are looking for from Discovery Alliance to support, and they want to use that feedback to go set priorities for funding agencies for future support. So, I imagine that people can send in the feedback that having more in-person gatherings and time to work together between collaborations is valuable. Doing it at RCW, as ISSC is doing through this fireside this brown bag lunch today, is seemingly a very good strategy, and I hope Bob and Phil and others are noting this and support that kind of interaction in future years. And I'm sure the individual collaborations themselves can also make their collaboration meetings a little bit more open to members of other science collaborations to encourage this kind of co-work. So, for example, the recent desk meeting, of course, has members that were in other science collaborations, and we could have a session, for example, that really encouraged inter-collaboration activities.
Thank you, Gautham. Going to invite Simona to unmute.
Yeah, we actually, when we have meetings among science collaboration chairs, we have mentioned the need to have more discussion and more meetings all together to really have a roadmap on what we will do and how we will do it, especially on the areas that have overlap between different science collaboration. We asked for funding to have such a meeting, but unfortunately we were not successful to obtain it from the Alliance. And I was wondering if we could have something more, if we could have more discussion and more interactions between the collaborations in the future. So I strongly support this idea, if Gautham or William can do that.
I also see Ashley's got her hand raised, so maybe we should go there.
I just want to add one tiny thing that's somewhat related, which is that I also just want to highlight what's on the slide deck from AGN, the helpfulness of the link frameworks, which is the software engineering team that you can get funding to work with. They see the nitty gritty of a lot of projects that different science collaborations are working on. And I'm sure they're actually building up really interesting institutional knowledge about it. And it would be interesting to get some of that fed back or have them give insights to the linkages that we don't even see as scientists.
That sounds good. Thank you, Ashley. Thank you, Simona. We do have time for another question, either from in the room or, oh.
Yeah, so slightly smaller scale than meetings, but at least one example between TVS and Stars Milky Way Local Volume is the Crowded Field Task Force. So yeah, they're not working groups. The working groups are largely within a particular science collaboration, but I don't know, I just have to come up with another name, I guess. Task Force seems fancy. But that the Crowded Field Task Force is joint between those two collaborations, and it's just a fortnightly, bi-weekly, twice monthly meeting between whoever cares about that topic, but it's joint. So that's another, smaller scale than meetings, but just come up with another word for another telecon and invite people from both collaborations to that as well. And Meg had a comment as well.
Yeah, thank you, Tom. Meg, if you'd like to speak to this, go ahead and unmute.
Yeah, thanks. I just want to highlight is that I think, or at least I feel like as a science collaboration co-chair, I'm quite worried about how do I get people together, because I'm looking at an entire list for a collaboration sprint in September, with many early career people telling me they need funding to be able to come, and me being able to go. I have a little bit to give because I can't, donors are not maybe necessarily giving. And so we all seem an interest to do this, but I don't see right now or funding agencies or where the opportunities are in funding that's guaranteed to help people, come together. And they're choosing, do they go to a regular science conference or do they go to a Rubin one? And or a Solar System Science Collaboration conference. And I worry about this because it means making students choose between presenting their current results, which is important for them being able to get jobs and, be seen and present their current work, while also sort of moving into Rubin, right? Which is still prep work, at least, and for the next year or two, right? The results will come in. And so I guess I just really want to highlight that I don't know where the opportunities are right now. And so it would be really great for those people that do have ideas of how do we get people together and the funding to bring these people to come together, especially between cross science collaborations, because it's not there. People can't spend their grants they currently have to work on LSST work right now. And I don't know if that's going to change by next year. So I think there's a really big need right now for getting funding or support for meetings and travel, right, to accommodate especially early career and those that are underrepresented in astronomy to be able to participate in these. So just wanted to highlight that. I think it's been said, but really highlight that that's one of my biggest concerns right now, is that when the data drops, will we be able to support that community and being able to attend a 3-day workshop, especially when right now I'm looking at the list of people telling me they would love to come and it would be great, but I can't help support that. So I just want to highlight, I think that's a bigger concern as we're moving to the next 2 years.
Thank you, Meg. Thanks for that. All right, we're right at the hour. Gautham, do you have any final comments before we end?
No, nothing from me. Thank you again to all of the speakers for keeping on time and giving us such a lovely view of all the science collaborations. Any other announcements, Melissa, before we run out of time?
No more announcements. I think we're done. I think another round of applause. Yep. Thanks, Gautham.
Fantastic.